Today, I am going to explain the experiment velocity and acceleration. The objectives of this experiment are to find the velocity and acceleration of an object in motion along straight line, one dimension. The second objective is to study the motion of object under constant acceleration. For this experiment, we are going to use the following apparatus. We are going to use a dynamic cart, dynamic track, angle indicator, photo gates, and smart timer. The theory behind this experiment are we are going to use four equations. The first equation we are going to use average velocity. We already studied the formula of average velocity, which is displacement divided by time, that is equal to x2 minus x1 over t2 minus t1. Here x2 is the final position, x1 is the initial position, likewise t2 is the final time and t1 is the initial time. And also we are going to use the average acceleration formula, which is change in velocity divided by time, which is equal to v2 minus v1 over t2 minus t1. And also we are going to use the equation of motion with constant acceleration. For that, we are going to take the second equation of motion with constant acceleration, which is given by the relation delta x, which is equal to v initial t plus half at square. Today, we are going to use this equation as the main equation for finding the acceleration. So what we are going to consider? We are going to consider the initial speed of the dynamic cart as 0. So if you consider vi is 0, then this term will be discarded. So we are going to use only delta x equal to half at square. By this relation, we have to rearrange this equation in terms of acceleration. So by that, what we will get? We will get the relation of acceleration as a equal to delta x multiplied by 2 divided by t square. So this equation we are going to use for finding the acceleration. So this is our experimental calculation. Now after we complete this experimental calculation, we have to compare our answer with a theoretical equation that is given by the rule A equal to g sine theta. So what is this A equal to g sine theta? We have to come for this free body diagram. So today we are going to use this dynamic cart with respect to some angle theta. So when you release this car at certain height, we have to consider the initial speed of the cart as 0. So here, once you release the car, it will be accelerating the direction of mg sine theta. So here the acceleration of the cart is only in the direction of the sine component. So you have to equate this equation with Newton's second law. So F is equal to mg sine theta, that is our acceleration force, and F is equal to ma, that is our Newton's second law. So what I did, the left hand side of the two equations are same, so I have to equate the right hand side equation. So if you equate this right hand side equation, ma equal to mg sine theta, mass left hand side and mass right hand side get cancelled. By that we will get the equation as a equal to g sine theta, and that equation was given here. So today we are going to use this equation for getting the answer for the theoretical calculation. That means we have to keep the dynamic track with respect to some angle theta. So by using the theta and g value, we are going to get the answer for the theoretical acceleration, and later on we have to compare the theoretical acceleration with the experimental acceleration. So by that, your answer should be closer to each other. Now I am going to show you what are the apparatus we are going to use in this experiment. As I already mentioned earlier, we are going to use a dynamic cart. You can see this. It has a 4 smooth wheel, and this dynamic cart we are going to use over the dynamic track. So if you see the dynamic track, we have the path for the dynamic cart. So you have to keep this dynamic cart over this track. By that, this dynamic cart will be moving smoothly. So by that, we can easily find the velocity and the acceleration of the object which is moving on a straight line. Clear? And then we are going to use two photo gates, photo gate 1 and photo gate 2. Why we are using these photo gates? We have to fix the photo gate at some location, and you can see here the dynamic track has the ruler. So that means our initial position of the cart we are going to place at the location of 20 centimeter, and we have to keep our cart very closer to the photo gate. By that, the initial position of the cart is considered to be 20 centimeter. And then we have to place the second photo gate at 40. So by that we can easily find the displacement between the two photo gates, which is 40 minus 20 gives the displacement of 20 centimeter. And these two photo gates are connected by the timer box, and here the timer box will give the time. So how much time this dynamic car will take to cross the photo gate 1 to 2. So that information we will get the dynamic the smart timer will record that time clearly here. And then we have the angle indicator, because today for this experiment we have to make this dynamic track not in the horizontal position, we have to make the dynamic track with respect to some angle. So for that purpose we are just using this angle indicator. I will just show you clearly very close to this. You can just have a look here. So here this angle indicator has a thread, and you can see this exactly at 0 degree. So that's the reason we consider this dynamic track is at horizontal position. So what we are going to do, we have to lift this dynamic track with the help of this wooden block. So what I am going to do, I am going to place this wooden block and I have to keep in this position, and I am going to lift a little bit, and I have to keep this wooden block exactly below the leg of the dynamic track. So now you can see this dynamic track will have some angle. After I put this to this side vertically, so what happened, now the dynamic track is kept at respective angle theta. So we have to use this theta for the calculation of our theoretical acceleration. So now you can see what is the angle here. The angle is between 0 to 5 degree. I think here we got exactly 4 degree. So that is the angle today we are going to use for our calculation. So today I am going to explain how to fill the data in the table. So before we start filling this table, we have to see some informations are given in the top of the table. So what is given? Initial position of the cart x1. So here what we did, we considered the initial position of the cart with respect to the first photo gate. You can see here we have to consider the initial position of the cart is exactly, because we have to keep our dynamic track close to this 20. So by that the initial position of the cart is considered to be at 20 centimeters. So I have to write this value here. So what I'm going to do, I'm going to write this value here. 20 centimeter is our initial position of the cart. And then initial start time of the cart, because we kept the dynamic car at rest, so that means the initial time as well as the initial velocity is considered to be 0. Clear? And then inclination angle, as I already mentioned, we have the angle indicator here. You have to closely see here. This thread is exactly touching some line, and I think here we have a 4 degree. Here we have closer, we have a 4 degree. Clear? So I have to write this angle here as a 4 degree. That is our inclination angle. And we know the acceleration due to gravity value g, which is 9.8 meter per second square. So today what we are going to do, we are going to fix our xi, that is our initial position, as a constant. We are not going to change this 20 centimeter. That means we are not going to change the position of the photo gate 1. Only we are going to move the photo gate 2 with respect to some different location. Clear? So by that we can easily find the displacement between the two distance. We have 40 here, we have 20. So displacement of this is nothing but final position minus initial position. We will got 20. So I am going to keep the initial that means the initial location of the cart, which is our photo gate 1, as a constant as 20. So now I am going to explain for only one data. In the similar way, you have to complete the remaining. So totally we have 4 datas, 1, 2, 3 and 4 datas we have to fill here, but I am going to explain for only one data, and in the similar way you have to do the same thing for the second, third and fourth. So let's see what is given in the table. In the first column we have change in position, which is delta x, x final minus x initial. So let's come back to the apparatus. What is x final minus x initial? You can see here x final is our second photo gate position, which is 40 centimeter, and your x initial is nothing but 20 centimeter. So what is your change in position? Final position minus initial position will give the change in position, which is our displacement. So 40 minus 20, we will get 20 centimeter, but we have to give the answer in terms of meter, so you have to write 0.2 meter. That is our first information. Now we are going to find what is the time travel. So that means T final minus T initial. So how we are going to find? I already told you we are going to use the smart timer, and this smart timer is going to give the answer. So here we have the power button here. You can see we have the power button here, and first of all you have to turn it on. By that the screen, the small screen is there, and now you can see there are three different color buttons are there: red color, blue color and black color. What is this red color says? The red color tells you about what type of measurement today we are going to do. What measurement we are going to do? We are going to measure the time. And then the second button indicates what type of mode. For calculating this measurement, what type of mode we are going to use. I will explain one by one. And then the third button refers to stop and start. Okay, so if you press this one time, then the screen will show a small star symbol. So once I start taking the data, I will show you one by one. Okay, what program we are going to use for this experiment? So what you have to do, first press one time. You can see time will appear. So by pressing this keep on, you will get different type of application. You can see first time when I press, time came. Second time I got speed. Third time I got acceleration. Fourth time I got count, and fifth time I got test. So that means totally 5 different type of measurements we can carry out here. But for our today experiment, we are going to measure only the time. So what I have to do, I have to press this button one time to select the time measurement. Now, what type of mode we are going to use? You can see here in this apparatus, we have two gates, two photo gates we have. So, we have to choose a 2-gate mode. So, I will show you the second button. Once we select the time, then we have to come for the second button. So, just press one time, you will get 1-gate mode. But we are having 2-gate, right? And then press second time, we got fence mode. And then third time, you got 2-gate mode. Fourth time, we got pendulum. Fifth time, we got stopwatch. But we just select only the 2-gate, that is for our calculation. So I have to press this for 3 times. By that, the 2-gate modes will be selected. Clear? So first step, we select the time. In the second button, we select the 2-gate mode. And then third, we are going to get the time, the answer for the time interval. So if you press this one time, you can see I'm going to press, you can see the screen. When you press one time, this apparatus is going to take data. So by that, you can see a star symbol there. So what is the star exactly says? The star symbol says the apparatus is ready to record the time. So that's the reason the star is up here. But once it detects the time, this star will gone and its respective time value will be displayed on the screen. Now, what I am going to do, we already fixed the first photo gate at 20 centimeter. Now I have to take the dynamic cart, and then I have to keep the dynamic cart very close to this. So how we have to consider the initial speed of the cart is 0. So for that, what you have to do, we have to press the start. By that, the star symbol will be there, and you can have a look here. The top, that is a small red color light is there. You can see when I just move this, you can see the red color light is there. So that means we have to place this dynamic cart very close to the photo gate. By that, this light should not be on. If the light is on, then it will not consider the initial speed of the cart as 0. So you have to place very close to that. By that, the light should not be on. So once you just start again, and when you leave the dynamic cart, the dynamic cart will be travel between photo gate 1 and photo gate 2. By that, its respective time taken will be given by the timer box. Okay, let's see. So what I'm going to do, first I have to keep near to this. You can see here. First I have to keep, because there is a light, I have to make the light to off. So I have to keep my track like this. Clear? And then I have to press the star one more time. Now I'm going to release. So now have a look here. 1, 2, 3. You can see here, we got the first time. So 0.9022. So this is the time interval between photo gate 1 and photo gate 2, this dynamic cart take. So I have to record this value. What's the answer here? 0.9022. Right? Okay, I have to fill this value. 0.9022. You have to write the data completely. Don't round out the number by yourself. We have to write the entire numbers, what is shown on the screen of the timer box. So once we find these things, once we find the time, we have to complete remaining thing by using our calculator. So what is given in the third column, we have to find time square. So you can see we have 0.9022 is the time. So I have to square this number. So 0.9022 square here I got the number as 0.8139. So here I can write only 2 digits. So if I want to write this number to 2 digit, I have to see the third digit. So third digit is less than 5. So I can write this number as 0.81. This is our time square. Now we can easily find the velocity. What's the formula for velocity? Delta x divided by t. So here delta x we already found as 0.2 and t already we have 0.9022. Once you divide 0.2 by this number, we can easily find the average velocity. So what I'm going to do, let's see here. I'm going to find the velocity. So 0.2 divided by 0.9022. So what answer I got? 0.22. So I have to write this value here. 0.22 is my average velocity. And then I have to find the average acceleration. What's the formula for average acceleration? Velocity divided by time. Velocity we already got as 0.22. And I have to divide this one more time by using the time. I have to divide the number of velocity by time. So that means 0.22 divided by the same time 0.9022. I will get the acceleration. So let's divide. The answer for the velocity is 0.22. So 0.22 divided by the time value here is 0.9022. 0.9022. Here I got the acceleration value as 0.24. So I have to write this number. So likewise, you have to take the data for the second and third and fourth. So how to do the for second? You can see we fix the initial position as 20, right? You can see here we fix the initial as a constant. I'm not going to touch anything. Only I'm going to move my second photo gate. So what I'm going to do, I'm going to move the second photo gate to 50. Clear? That means 50 is my final position, 20 is my initial position. So that means 50 centimeter minus 20 centimeter, what we got? So 50 minus 20, which is a 30 centimeter. And we have to give the answer in terms of meter, which is 0.3 meter. And again, what you have to do, you have to bring the dynamic cart near to the photo gate, and then you have to press the star again, and then press the star again, and then release the dynamic cart. By that, what will happen? The dynamic cart will be moving between these two photo gates, and for that its respective time will be given by the timer box, and you have to record the time. Once you record the time, and you have to square the time, and then you have to find the velocity by using this formula, and then you can find the average acceleration by using the formula. So likewise, we have to do the same thing for the step 2, 3 and 4. So by that, what will happen? You can easily complete the table. Once you complete the table, what we have to do? We have to draw the graph. For what we are going to draw the graph? Delta x versus t square. So you have to see the table. We have delta x here. That means all these values are in your x-axis. So all these values are in your y-axis. Generally, the first should be in y-axis and the second should be in x-axis. So we have to take all the delta x value in y-axis, and we have to take all the t square value in x-axis. By that, what you will get, I can just draw the diagram here. So you have to take delta x value in y-axis, its unit is in meter, and then the time square value, its unit is second square. Fix the point by using your pencil and connect the points by using the ruler, and then choose any 2 points on the line, and by that you can get y1 and y2, and this is your x1 and this is your x2. By that we can easily find the slope. So what's the formula for the slope? Delta y over delta x, right? And what is this y over x? When y-axis we took delta x, right? And in x-axis what we took? T square. So that means after you find the answer for the slope, that answer is exactly equal to delta x over delta t. So if you expand this equation, which is y2 minus y1, x2 minus x1, and once you substitute the value, you will get the answer, and the unit for this is y over x, which is meter over second square. So the unit for the slope here is meter per second square. Once you find this, what we have to do, as I already mentioned, we are going to use the equation a equal to 2 multiplied by delta x over t square. So here delta x over t square is nothing but your slope answer, because your slope is delta x over t square. So you have to take the slope and you have to substitute here. So by that, what will happen? You will get the equation as 2 multiplied by slope, because here delta x over t square is a slope. So 2 multiplied by slope, you will get one answer. And then we have to find the theoretical answer, which is a equal to g sine theta. G value we already know. What's the value of g? Which is 9.8. And then sine of theta. What theta? I have to go back to the table. You can see what theta we wrote here. 4 degree, right? So I have to take this angle. And then I have to use it here. When you use your calculator, you will get one answer, right? And this answer, which is our experimental answer, should be closer to your theoretical answer. So after you find the theoretical value of the acceleration and the experimental value of the acceleration, you have to find the error percentage. So usually the error percentage, after you substitute the value of the experiment value and the theoretical value, the answer for the error percentage should be between 0 to 10%. Clear? So if you do it properly, for sure, your error percentage answer will be between 0 to 10%. So in this way, you have to complete this experiment. That's it. Thank you.